In the time it takes to snap your fingers, the sun releases enough energy to power an entire civilization for 4,500 years. So naturally, scientists and engineers have been working to build a meteor star here on Earth to plug into the power grid. And the thing is, we already kind of have. It doesn't look like a tiny star floating in a lab. Star is made of almost incomprehensible number of particles which gravity compresses into the super dense core. This core is hot and dense enough to force atomic nucleus together, forming larger, heavier nuclei in a process known as fusion. The reverse process where one atom splits into two is called fission. In both processes, the mass of the end product is slightly less than the mass of initial atoms, but that loss mass doesn't disappear. It's converted to energy according to Einstein's famous equation. And since C squared is such a mass number, both fission and fusion generate a lot of energy. Fusion in your sun mostly produces helium nuclei. In the most common pathway, two protons fuse to form a deuterium nucleus, which then fuses with another proton to form helium-3 nucleus, which then fuses with another helium-3 nucleus to form a helium-4 nucleus. But there's a catch. The first step is incredibly rare. Only 1 in 100 septarium collisions between protons result in a deuterium nucleus. In the sun, this is a problem because there are so many protons that even in reactors, this rare happens all the time. But on Earth, researchers rely on the more easily reproducible reaction, where deuterium nucleus fuses with tritium nucleus to form a helium-4 nucleus and neutrons. We actually doing reaction like this one inside particle accelerators since the 1930s, but these accelerators are not designed to harness the energy this reaction releases. Rather, they are used to generate neutrons for a variety of scientific and military purposes. Whereas, if we want to use fusion to produce limitless energy, we need a device that can harness the energy released, channel enough of that energy back into the device to keep the reaction going and send the rest out to a power grid. And send to a rest out to a power grid. And send to a rest out to a power grid. And for that job, we need a nuclear fusion reactor. Like a particle accelerator, reactor would generate helium nuclei and neutrons, but the reaction would happen in the superhot core. And the resulting neutron would shoot outward to heat up a layer of lithium metal. The heat would then boil water, generating steam to run turbines that produce electricity. Meanwhile, helium nuclei would stay in the core and slam into other nuclei to keep the reaction going and the electricity flowing. This tech has many practical challenges, including how to find the swirling mass of million-degree matter. The biggest hurdle is achieving what's called ignition. Energy technology is only commercially viable if you put outwards more energy than it uses. The fusion reactor needs a lot of energy to get hot core enough for fusion to occur. So there's a tipping point, a moment when fuel is hot enough to start a reaction and release more energy than is needed to reach a maintained temperature. This is ignition. Stars reach ignition under the forces of huge amounts of gravity, but this approach is impossible on Earth since you need thousands of tons of mass of, well, the entire Earth. So researchers typically rely on vast arrays of lasers or missiles that combine magnetic with high-energy particles or electromagnetic waves similar to those in your microwave oven. In 2022, scientists at the U.S. National Ignition Facility demonstrated ignition for the first time ever, using 192 lasers to heat deuterium to 100 million degrees. Where this is a huge step forward, we still are ways off from self-sustaining long-running reactor that produces more energy than it uses. But one But once operational, these relatively small reactors could power a city of 1 million people for a year with just 2 pickup trucks of fuel. Today, you had to burn roughly 3 million tons of coal to produce that much energy. That is the promise of fusion, limitless on-demand energy with almost no emissions. True star power right here on Earth.